Hey y'all, welcome to West Texas 3D Printing, tutorials curated by nerds, delivered by your favorite narrator, Lulu. Supports exist to hold up parts of a model that would otherwise sag, collapse, or print in midair. Understanding when to use supports and when not to is one of the fastest ways to improve print quality and reduce cleanup. Let's go through the principles, the types of supports, and how to choose the right amount. First, when supports are required. Supports are needed whenever the printer must create an overhang that exceeds its comfortable angle. For most printers, anything steeper than about 45 degrees from vertical may need support. Some models can push to 55 degrees, but steep angles almost always require support. Flat horizontal features, like chins, shelves, or ledges, need support unless they are very short. Now, when supports are not required, gradual slopes usually print without support. Curves that rise slowly are self-supporting. Domes and rounded surfaces often print cleanly on their own. If the angle is gentle, each layer has time to cool before the next one is placed. Use supports only when the geometry truly requires them. Next, types of supports. There are two main categories: normal supports and tree supports. Normal supports form straight vertical columns under overhangs. They are strong, predictable, and work best for mechanical parts with flat surfaces. Tree supports grow outward like branches, bending toward the overhang instead of rising straight up. They use less material, remove more easily, and are ideal for organic shapes and detailed models. Tree supports are best for figurines, characters, sculptures, and curved surfaces. Normal supports are best for brackets, boxes, enclosures, and flat mechanical parts. Now, support density. Density controls how solid supports are. Higher density makes supports stronger but harder to remove. Lower density makes them easier to peel away but weaker. Typical values are 10 to 15% for tree supports and 15 to 20% for normal supports. Heavy flat overhangs on mechanical parts may need higher density. Next, the support interface. The interface is the thin layer between the support and the model. It creates a controlled breakpoint for removal. For PLA, two interface layers usually work well. For PETG, reduce interface layers to avoid bonding too tightly. For ABS and ASA, keep the interface sparse for easier removal. More interface layers improve surface quality, but make removal harder. Now, Z-distance, also called support gap. This gap controls how close the support is to the model. A larger gap makes removal easier, but reduces surface quality. A smaller gap improves surface quality, but risks fusing the support to the model. Typical values are about 0.2 millimeters for PLA, 0.3 for PETG, and 0.2 to 0.3 for ABS and ASA. Now, support placement. Good support placement follows three rules. Support steep overhangs, avoid touching visible surfaces when possible, and avoid filling tiny internal cavities unless absolutely necessary. Use support blockers to prevent unnecessary supports in clean areas. Use support enforcers to force supports where the slicer misses small overhangs. Now, bridging. Bridges are horizontal spans between two anchor points. Short bridges often print fine without support. Long flat bridges sag unless supported or sliced with special bridge settings. Short bridge, no support needed. Long flat bridge, support recommended. Curved underside, tree supports usually work best. Next, support angle. Support angle determines when the slicer generates supports. For beginners, 45 degrees is a safe default. For gentle shapes, increase to 50 degrees. For detailed figurines, lower to 35 or 40 degrees for better coverage. Now, orientation and supports. Before adding supports, rotate the model. A small tilt of 10 to 20 degrees can eliminate many unnecessary supports. Orientation is often more effective than changing support settings. Now, removal. Tree supports usually peel away cleanly when printed dry and at the correct temperature. Normal supports may need pliers or flush cutters. Never rip supports aggressively. That can tear the surface of the model. If supports stick too hard, lower bed temperature, increase Z-distance slightly, reduce interface layers, or rotate the model. Now, signs that supports were poorly configured. Stringy or sagging overhangs mean not enough support. Scars, pits, or rough surfaces mean supports touched visible areas. Supports fused to the model mean the gap was too small or temperature too high. Supports snapping early mean density was too low or the wrong support type was used. Finally, the support decision checklist. Do I have steep overhangs? Do I have flat horizontal features? Will this surface be visible? Can I rotate the model to reduce supports? Should I use tree or normal supports? What density is appropriate? How will supports affect surface cleanup? If you answer these questions, you'll choose the right support strategy every time. Supports aren't just objects under a model, they're part of the design and slicing process. When configured correctly, they give clean overhangs, crisp edges, and predictable results. Thanks for watching from all of us at West Texas 3D Printing. Yes, even me, Lulu. Like, subscribe, and keep turning chaos into clarity.